All right. The first section was factoring. So what's the first thing that we always want to look for when we're factoring? GCF. Okay, so on number 1, we can take out a GCF. I can take an A out of both of these terms. Right? So when we take an A out, what am I left with?
Just
So here I would just be left with A minus E. Can I do anything else? Can I factor this A minus 8 any further? No. Right? That's it. A times A minus 8 is all I can do for the first one. Right? The second one, is there a GCF? No. So we have to X factor. Right, so I want two numbers that multiply to negative 42 that add to positive 1. What numbers multiply to negative 42 and add to 1? Negative 6 and positive 7. So, since my leading coefficient is 1 here, right, since my leading coefficient is 1, I can go straight to factors. So I don't have to do factor by grouping. My factors will just be n minus 6 and n plus 7. And that's it. That's my answer. Right, how about on number 3 here? Is there a GCF? No. Right, 3, 2, and 40 aren't all divisible by the same thing. So we have to X factor. And on this one, since my leading coefficient is not 1, I will have to factor by grouping. So 3 times negative 40 is negative 120, and then my B is 2. So 2 numbers, negative 10, and positive 12. So here, what I do with those numbers, okay? Yeah, factor by grouping. So I'm going to split this 2n up into negative 10n plus 12n. Okay, so the 3n squared and the negative 40 stay the same. Then I just group the first 2, group the second 2, and look for a GCF. So between 3n squared and negative 10n, what can I take out? 10 isn't divisible by 3. Did you do the 12 first and then the 10?
Yeah.
Okay.
You can take out 2.
3 isn't divisible by 10.
Just
Yeah. So here, yeah, we could. The only thing we could do is take out an n, right? If you flip these, that's perfectly fine. You'll still get the same answer. Okay. And if you did flip these, you could take out a 3n. But the way I did it, we could only take out an n. Left with 3n minus 10. Then how about the 12n and the 40? What can I take out of both of those? 4. Yep. So if I take a 4 out, what am I left with?
3 minus.
Yep. All right, remember, taking something out means we're just dividing both terms by that. So 12n divided by 4 would be 3n. Negative 40 divided by 4 is negative 10. So now, at this stage, these two factors better be exactly the same. They are. So what's my final factorization here? Yeah. n plus 4 and 3n minus 10. Okay. Okay with that one? Alright, how about the last factoring one here? 12k squared minus 100k plus 112.
Do you
Okay. After what? Yeah, so the first step should be to look for a GCF. Is there a GCF between 1200 and 112?
Seems like
It seems like it. We could take out a 4. Right, so if we take out a 4, what are we left with? So taking a number out will make our factoring a little bit easier. Okay, the numbers are smaller then. So now I will still have to x factor this. Alright, so I want 3 times 28 gets me 84, and negative 25. So I want two numbers that multiply to 84 that add to negative 25. Negative 21 and negative 4. Negative 21 plus negative 4 is negative 25. Negative 21 times negative 4 is positive 84. So now I will have to factor by grouping. So that means I'm splitting up this negative 25k into negative 21k minus 4k. And then I group the first two, group the second two, and look for a GCF. So first, we got 3k squared, negative 21k. What can I take out of both of those? Yeah, I can take a 3k out of both of those. So I'm going to leave that 4 out front for now. So if I take a 3k out, what am I left with? Yeah, I'm left with k minus 7. Then how about between these two, negative 4k plus 28? What should I take out of both of those? I can take a 4 out. I can actually take a negative 4 out. Right? So that then, if I divide both of these by negative 4, I'm left with k minus 7. So now, the final step, since I am left with the same factor here, this will be 4 times 3k minus 4 times k minus 7. Right? One thing I do see people leave off a lot is that 4 that we took out at the beginning. Okay? That still needs to be part of the final answer. Okay? We should write that 4 out in front of our two factors. Right? Questions on factoring? Alright, then the next part was just simplifying a rational expression and stating excluded values. So again here, a lot of factoring. How about this first one? 28r to the 4th over 14r. How would I simplify that? Yeah, just divide it. You're simplifying this fraction. So first, 28 over 14, how can I reduce that fraction?
It's just 2.
Yeah, 28 divided by 14 is just 2. I could take out a 7, but I could actually take a 14 out of both of them. Both of these are divisible by 14. So this would actually just reduce to 2 over 1. Right? I don't have to write the over 1 part. Right? I could just say it's 2. Then how does r to the 4th over r reduce?
It would just be
It would be r to the 3rd, exactly. Right? Because this is the same as r to the 1st. So when I've got variables over each other, I would just subtract the exponent. So this would be r cubed on top. Okay, so I don't even have to write this over 1. I can just write 2r cubed. So that's my simplified answer. Then I still need restrictions. Remember, restrictions come from every factor of a variable in the denominator. So in my original denominator, I just had 14r. What would my restriction be then? R can't equal 0. Exactly. Alright. So then on the the next one, we need to factor everything that we can. Right? So in the denominator here, k squared minus 7k plus 6, what can I do with that? Like an x factor, yeah. So I'm looking for two numbers that multiply to 6 that add to negative 7. Negative 6 and negative 1. And now my leading coefficient was 1, so I can go straight to factors. So this will just become k minus 6 over k minus 6 times k minus 1. Now what? Yeah, now I can start canceling stuff out. Here, I've got k minus 6 and k minus 6, so I can get rid of both of those. So then what's my final simplified version? So this is a mistake I saw a lot of people make on the graded assignment. Right? If we're just left with one factor, but it's in the denominator, we still have to have a numerator. Right? We can't just move this to the numerator. So if I cancel everything out in the numerator is now 1. So this would still be 1 over k minus 1. Right? Then I still need my restrictions. So restrictions come from every factor in the denominator before we cancel anything out. So I've got 2 of those. So what value of k would make this factor equal to 0? Positive 6. So k cannot be positive 6. And this one? Positive 1. Yeah. So my answer is 1 over k minus 1, where k cannot equal 6 over 1. Alright. And the rest of these are a lot of factors. Right? So on number 7, in my numerator, I've got 5n squared plus 25n. What can I do there? I can take out a 5, yeah. 5 and 25 are both divisible by 5. Is there anything else I can take out? I can take out an n as well. Alright. So what am I left with then? I would be just left with n plus 5, right? Then in my denominator, I have n squared minus 5n minus 50. What can I do with that? X factor it. So I want two numbers that multiply to negative 50 that add to negative 5.
5 and 8.
5 and negative 10. So my leading coefficient was 1. I can go straight to factors. So we have n plus 5 times n minus 10. Now I've got everything factored. I can cancel out these factors that are the same, the n plus 5s. So I'm just left with 5n over n minus 10. And then my restrictions will be whatever values of n make the denominator equal to 0 before we canceled anything out. So what value of n would make this first factor, n plus 5, equal to 0? This one would be positive 10. Yeah. And how about this one? Negative 5. So we have two restrictions. N can't be 10 or negative 5. All right. Are you okay with that one? All right, so this last one was a decent chunk of factoring here. Scroll up to get a little more room. So, how about in my numerator here? Can I take out a GCF?
You want 8?
Hmm?
You want 8?
question, are you on 8?
Oh, yes.
Expect.
Yeah, we have to X factor. There's no GCF. So for the numerator, 3 times negative 14 is negative 42 and negative 19. So two numbers that multiply to negative 42 and add to negative 19.
Can't do them all then.
What are two numbers that multiply to negative 42 that add to negative 19? 2 and negative 21. Right. So I will have to factor by grouping here. So let's say 3n squared plus 2n minus 21n minus 14. So group the first two, group the second two. What can I take out of the first two? 3n squared plus 2n. I could take out an n, so I would be left with 3n plus 2. How about in this second pair? How about in this second pair, what can I take out of both of them? Seth, what do you think? I think in both of these I can take out a negative 7. So I'd be left with 3n plus 2.
How did you get negative 7?
So I've got negative 21 and negative 14. So the largest number that both of those are divisible by would be 7. Right? Since they're both negative, I can actually take out a negative 7. And I want to make sure at this stage then that these two things are the same. To make them the same, I would have to take out a negative 7. So if I took out a positive 7, this would be negative 3n minus 2. So now since these are the same, my final factored form would be n minus 7 times 3n plus 2. So I can put that in my numerator here. N minus 7 times 3n plus 2. Now I still have to factor the denominator. So I guess first, is there a GCF in my denominator? 7, negative 48, and 7, are those all divisible by the same thing?
That 48 is divided by 7.
48 does not divide by 7 now. 49 does, but not 48. So, X factor. So, in my top here, 7 times negative 7 is negative 49. My middle term is negative 48. So I want two numbers that multiply to negative 49 that add to negative 48. 1, negative 49. So I will set up my factor by grouping. So 7n squared plus n minus 49n minus 7. Group the first two, group the second two. So what can I take out of 7n squared and n? Just an n. So what am I left with then? 7n plus 1. And what can I take out of negative 49n and negative 7? Negative 7. So then I'm left with positive 7n plus 1. These are the same, so my final factored form then would be n minus 7 times 7n plus 1. So 7 times 7n plus 1, and we can cancel out these n minus 7's. So my final answer is 3n plus 2 over 7n plus 1. And we still need our restrictions. Right? So we can say n cannot equal what? And remember, these come from our denominator before we canceled anything out. So 7, right? That one's pretty obvious from this factor. Yeah, so then from this one, it's not so obvious. The answer is -1/7. Okay, but to get that, remember, we're thinking about saying, well, I'm going to take that factor and say that cannot equal 0. Okay, so if it's not immediately obvious, right, this one is, right, 7 minus 7 is 0, but this one might not be. So we can just set that equal to 0 and solve. So subtract 1, we get 7n equals -1, divide by 7, we get n cannot equal -1/7. Okay, so this is my answer. Questions? All right. Then let's do some multiplication and division. Yeah, right?
Yeah.
All right, so multiplication, remember, we're just thinking about that as one big fraction. Right? Once I have everything factored, I'm just turning this into one huge fraction. In this first one, everything is already factored for me. So I can go ahead and just start canceling out any common factors. So let's see a 4x squared and a 4x squared. Get rid of those. I see an x plus 4 and an x plus 4. Get rid of those. And then I'm just left with x minus 4 over 6x squared. Then we need our restrictions. So the restrictions come from all of the factors in the denominator before we canceled anything out. So this 4x squared, what value of x would make that equal to 0? X can't equal 0, right? Because 4 times 0 is 0. What about in this one, x plus 4? What value of x would make that piece equal to 0? X cannot equal -4. How about this last one, the 6x squared? 6 times what squared is 0? Yeah, this one's just 0 as well, right? 6 times 0 squared is 0. So we don't have to write that again. So my only two restrictions end up being 0 and -4. Okay. So let's come over here to the next one. This one, there is a little bit of factoring to be done, okay? To get our restrictions. We could actually say, well, here I've got a 10r squared minus 10r. Here I've got a 10r squared minus 10r. I could actually just cancel out those two things because they're exactly the same. But to get my restrictions, I will eventually have to factor. So we might as well just go ahead and do that right now. So I've got 10r squared minus 10r. What can I do with that? I can take out a 10 and an r. Right? So then what am I left with? R minus 1. Can I do anything with the r minus 6? Nope. Then over here, we got 4r squared, and then the denominator is the same as the numerator in the other one, so that will factor the same. 10r times r minus 1. So now we can cancel what we want. The r minus 1s, 10r's, and we're just left with 4r squared over r minus 6. And then we need our restrictions. So the first factor that was in the denominator was r minus 6. What value of r would make that equal to 0? 6. Then my next factor is 10r. What value of r would make that equal to 0? 0. And then my next factor is r minus 1. What value of r would make that equal to 0? Positive 1. All right, so in this case, we got 3 restrictions. All right. On the Next one, again, we'll have to do a little bit of factoring here. So 2n minus 2, can I do anything with that? I can take a 2 out of both of those. So what am I left with then? N minus 1. How about in the denominator here? N squared plus 6n plus 9.
2 out of 3.
Or, yeah, there isn't anything in front of the n squared that's divisible by 3 plus. So it's a good thought, but in this case, we cannot. We just have to x factor. So I want two numbers that multiply to 9 that add to 6. 3 and 3. So in this case, my leading coefficient is 1, so I can go straight to factors. So my factors are just n plus 3 and n plus 3. So then over here, I've got n plus 3 in my numerator. Nothing I can do with that. Here I can take out a 2. So I can make this 2 times, I'd be left with n plus 5. Now I can cancel stuff out. Right? I've got n plus 3's here. I've got 2's here. I can cancel those out. Now, another common mistake I've seen people make is just go ahead and cancel out all these n plus 3's. Okay? We cannot do that. We can only cancel out pairs that are exactly the same in the numerator and denominator. Here I had 2 factors of n plus 3 in the denominator and only 1 in the numerator. So I can only cancel out one of the ones in the denominator. The other one will have to stay. So then I'm left with n minus 1 over n plus 3 times n plus 5. Now, my restrictions. I want to look at all the factors before I canceled anything out. So up here, n plus 3, what value of n would make this equal to 0? Negative 3. This one is obviously the same. How about the 2? Do I get a restriction from the 2? No, right? Only when we have a variable. How about the n plus 5? Negative 5. So in this case, we only had 2 restrictions. Okay with that one? Our last multiplication one here, in the 9x plus 45, can I do anything with that? What can I do? I can take out a 9. So if I take out a 9, what am I left with? X plus 5. Then, obviously, that 9 will have to stay. Then over here, 21x plus 6. Maybe we could do something. We could take a 3 out of both of those. So if I take a 3 out, I'd be left with 7x plus 2. Right. So now in my denominator, 7x squared plus 51x plus 14. First, I take out a GCF. Is there a GCF between 7, 51, and 14? No, there's not. Right? So we will just have to X factor. So 7 times 14 is 98, and then 51. So 2 numbers that multiply to 98 that add to 51. 49 and 2. So I will have to factor this by grouping. So I can set this up as 7x squared plus 49x plus 2x plus 14. Right. Then group the first 2, group the second 2. So what can I take out of these first 2? I can take a 7x out. And then I would be left with x plus 7. How about in this second pair? Take a 2 out. I would be left with x plus 7. So my final factored form, x plus 7 times 7x plus 2. Now I can cancel some things out. Right? These 9s will cancel. These 7x plus 2s will cancel. And then it looks like we're just left with 3 times x plus 5 over x plus 7. Then we need our restrictions. So again, we look at our denominator before we canceled anything out. So how about the 9? Does that give me one? Nope, there's no variable. The x plus 7. Negative 7. And then the 7x plus 2. That one's not as immediately obvious, right? So how could I figure that out?
You have to like set it up and, I don't know, -1. You know.
So we want to set it up by saying 7x plus 2 cannot equal 0, right? And then solve that two-step equation. So minus 2, you get 7x cannot equal 2. By 7, so we get x cannot equal negative 2 sevenths. Alright, you okay with that one? Alright, then the final section was division. So division is pretty similar to multiplication, except there are 2 small differences. First is that we can turn this into a multiplication problem by taking the reciprocal of the second fraction. Right? So the first step in division is just rewrite it as a multiplication problem. So the first fraction will stay exactly the same. And I'm just going to then change this to multiplication and flip the second fraction. So this will be like this. Now in this problem, everything was factored for us already, so I can just go ahead and start canceling things out. So I can cancel out these b plus 1s, these b plus 3s, and then I'm just left with b minus 9 in my numerator over 8 times 2b. I can go ahead and multiply those together. 8 times 2 is 16, so 16b. Then I need my restrictions. Okay, so the restrictions on division come from anything that was ever in a denominator. Right? So that's the second difference between division and multiplication. So here, I can start with these denominators. Right? So my first factor is b plus 1. So b cannot equal negative 1. My next factor is 2b. So b cannot equal 0, right? Because here we're multiplying, so 2 times what equals 0? 0. Right? 2 times negative 2 would be negative 4. That doesn't do us any good. So we want 2 times 0. Then my next one is b plus 3. So that would be negative 3. Now the tricky part for division, okay, is then remembering to look back at what was originally my denominator. Okay? So this b minus 9 was also in the denominator at one point. So we have to look at that factor as well. So what value of b would make that denominator 0? Right? So in this case, we end up with 4 different restrictions. Right? For the next one, we'll have to do some x factoring for both the numerator and denominator over here. But remember, our first step is just to rewrite the problem as a multiplication problem. So the first fraction stays exactly the same. I flip the second fraction. So now let's do some x factor. Okay, let's x factor this numerator here. So I want two numbers that multiply to negative 18 that add to negative 3. And negative 6. So since my leading coefficient was 1 here, I can go straight to factors. So this will just become n plus 3 times n minus 6. Then I need to x factor the denominator. So I want two numbers that multiply to 60 that add to negative 16. Negative 10 and negative 6. And again, my leading coefficient was 1. So those are my factors. N minus 10 and n minus 6. So then we've got times n minus 10 over 3. I can cancel stuff out. Okay, so I can cancel out these n minus 6s, these n minus 10s, and I'm just left with n plus 3 over 3. Then we need our restrictions. So n cannot equal, let's see, from my denominators here, I've got n can't be 10 or 6, but then, so then here I just get a factor. But then I have to think, well, this n minus 10, bless you, this n minus 10 was in the denominator at one point. So this n minus 10 would get me a restriction of 10, but I already have that one. So here I only end up with 2 restrictions. Questions on that? Alright, I think we've got time for one more. Probably not both of them. We'll do one of them here. Alright, let's take a look at 15. So on this one, again, first step is to rewrite it as a multiplication problem. So that means first fraction stays the same. Second fraction, I flip. Plus 36. Alright. So again, like one of the problems we looked at before, I can see right off the bat this 35m minus 5 and this 35m minus 5 are exactly the same. So I could go ahead and cancel those out. But it's going to be a little bit easier to do restrictions if I go ahead and do the factors. So I can take a GCF out of 35m minus 5. I can take a 5 out, and I would be left with 7m minus 1. So obviously this one would factor the same. 5 times 7m minus 1. Then in my denominator here, 9m plus 36, I could take a 9 out of both of those, and I would be left with m plus 4. So now I can cancel out 5s, I can cancel out the 7m minus 1s. I'm left with 10 over 9 times m plus 4. Now, my restrictions, again, come from anything that was ever in a denominator. So m cannot equal, I don't get anything from this one, right, because there's no variable. 7m minus 1, if I set that equal to 0 and solve, I would end up getting 1 to 7. The 9 I don't get anything from. The m plus 4 I would get negative 4. And then my other factor that was in the denominator, this 35m minus 5, we can see was 5 times 7m plus 1, or 7m minus 1, sorry, which would get us the same restriction here, 1 over 7. Alright, so we don't quite have time to do the last one. Quiz tomorrow will look very similar to this. Alright, any questions? It'll be right around 50. I don't know if it'll be exactly 50, but pretty close to that.